Hi guys, I hope everybody's having a great day. This is just gonna be a real quick video on how we describe data. So now that we know how to graph data using histograms and box plots like we learned last week, we need to move into how to describe the data that we have. So there are four elements that you have to consider when analyzing data. The center of the data, so what's around the middle of your data, the spread of the data, how far spread out it is, the shape of your data, and the outliers. So I'm actually going to scroll down and I'm going to do outliers first, and then we'll come back to this other stuff. So the first thing that you want to consider in all of your data sets is if they have an outlier. So outliers are considered the values that lie outside of all of your other values. So you have all of these that are really close together, and then you have a data point that's really, really far out here. This is called your outlier. Outliers cause your mean or your average of your data to be skewed or pulled to one side or the other and not represent the true average of your data. So for example, this is an example, long jumpers extra distance they have added to their jumps by practice this month. So let's just say your school's track team is practicing and they're trying to make their jumps be longer, and then they collected all this data and they were just collecting how much further in meters people's jumps were based on all of this extra practice. So you have all of these people over here who have the positive like 0.06, 0.11, 0.12, 0.15, and these are all relatively close together. And then you have Sam over here who's at a negative 0.56 meters in his jump. So he actually got a shorter distance by all of the practice that they did. So you can see that Sam is clearly an outlier because he's really far away from all of the other people in this data over here. So what that does is it actually takes the mean, which is the average, we'll talk about here in a second, and it actually pulls it down towards Sam. So if we were to remove Sam as an outlier, what that does is it actually puts the mean or the average right in the middle. So whenever there's outliers, you just have to be really careful using a mean because it's going to be pulled towards whatever that outlier is. Okay, so to go back to the other important stuff up here is center. So the other one that we need to consider is the center. The measure of central tendency is a single value that attempts to describe a set of data by identifying the central position or the center within that data. So there's two things that we can use to describe measures of central tendency. The first thing is the mean, which is the average of the numbers. So that's seriously, you take all of your data, you add all of those up, and then you divide by the total numbers, and that gives you the average or the mean. And this is susceptible to outliers, just like we just saw. So if you have outliers in your data set or it's skewed, which we'll talk about here in a minute, you don't want to use the mean to describe your center of data. Then you have the median. The median is the middle number when the numbers are put in sequential order. So you put all of your numbers in order, lowest to highest counting order, and then you just work your way in and you find the middle of it. So we did do this in the video last class. So median is the middle when put in sequential order. And this one, if you have outliers, is the one that you want to use. So it says when to use the median. When there are outliers in the data set, meaning the data is skewed or not symmetric. So if you have outliers, you want to use the median. When to use the mean. Use when the set of data does not contain outliers or numbers that are much larger or smaller than most of the others. This means the data is symmetric and not skewed. So if you do not have outliers, you want to use the mean. So notice the way you describe the center is all about if there are outliers or not, and if it is skewed or not. Okay, the next thing we're going to talk about is the spread of the data. The spread of the data is how far away your data points are from the middle. So are they really spread out, or are they all really close together? And a couple ways that we can do that is we can do that with the range. So we can do the maximum minus the minimum, which is your range, but this isn't a really good value for finding the spread. It's one that is used, but not often. Another one is the interquartile range, or the IQR. So if you think back to our box and whisker plots, the IQR is taking the quartile 3 and minusing the quartile 1 from it. So Q3 minus Q1. So remember, when you go back to those single variable stats, you guys can just find these values and subtract them. And you're going to use this when there are outliers. Standard deviation is a number that is used to tell you how good of a measurements are for a group. A number used to tell how measurements for a group are spread out from the average or the mean, and it is not a good measure when there are outliers. So again, this is based on the outliers. If you have outliers, you want to use the interquartile range to describe the spread. If you don't have outliers, you want to use the standard deviation. And we'll learn a lot more about standard deviation next week. So a low standard deviation means that most of the numbers are really close to the average, meaning your data is not super spread out. A high standard deviation means that the numbers are way more spread out and that your data is really spread out. So a way to think about this is a real world example. So right now they're working on creating a treatment or a vaccine for the COVID virus. And if they were collecting data on how successful it was, what would they want the standard deviation to be? A low number or a high number? So would they want all of the data to be successful and be really close together, or would they want the successes to be really spread out? The answer to that is probably a low standard deviation. A lot of things that we do statistics on, we like to have a low standard deviation, because that means there's low variability, and that your treatments and vaccines are all working together in a nice small range of values. So it's really close together instead of being really spread out. So we'd want a small or low standard deviation. And then on the calculator, this is under your one variable stats, and it's this SX is your sample standard deviation, and this little like sideways P is your population standard deviation. They both work. For my class, you're probably going to use the one that has this sideways P, and I'll explain next week how you know the difference of when to use which one. So at this point, use whatever one. And then I just want to remind you guys how to get there in your calculator. So if you go to your calculator and you do stat, edit, and you enter all your data in here, so it's just random data I have, I can go over to stat, calc, and then I can do this one variable stats. And this will give me everything that I want to know. So this is my average. The X bar is my average or my mean. These are where you find your standard deviations. We're going to probably use this one for my class. And then if you arrow down, you again get that 5-number summary. So if you want to do the interquartile range, this is your Q3 and this is your Q1, you subtract them. If you want the range, you do the maximum minus the minimum. And then if you want the median, this is your value. So to get all of the things we just talked about in here, you just go to that one variable stats. You can get the mean, the median, the range, the interquartile range, and your standard deviation. Okay? Next thing we need to talk about is we need to talk about the shape of the data. So when describing a histogram, you need 2 descriptions. First, you're going to start with deciding if it is one of the following. It's either uniform, single-peaked, or double-peaked. Uniform means that the bars are similar height. They're all about the same height. Single peak is the graph has a single area where the data is the highest. In double peak, the graph has 2 areas where the data is the highest. So everything is going to have one of these in histogram. So you decide one of these answers. And then next, you decide if the graph is one of the following: symmetric, skewed left, or skewed right. The only description you need for a box plot. So if you have a box plot, these are the only things that you can say is they would be symmetric, skewed left, or skewed right. Symmetric is when one of the sides of the graph looks like the other. So your sides on both sides look the same and they're symmetric. Skewed is when data falls more heavily to the right or to the left, not in the center. Skewed left is the peak is on the right and it looks like a left foot, whereas skewed right has the peak on the left. So this is kind of backwards and this always gets me. So we'll go through a description down here. So for each of the graphs below, we're just going to describe them. So remember, the first thing is, are they uniform, single peak, or double peaked? And then are they symmetric, skewed left, or skewed right? Okay, so let's talk about this one. Let's think, is this uniform, single peak, or double peak? To me, it looks like all of these bars are relatively the same height. So we're going to say that this is a uniform. And then the next thing we have to decide is if it is symmetric, one side of the graph looks like the other, or skewed. So to me, this looks like it's pretty symmetric. Both sides look the same. So this is a uniform symmetric histogram. Okay, in this one, you can see that there are 2 clear peaks. So this one is actually a double peak. And then it does look symmetric. So this side kind of matches this side. So I would say this is a symmetric. Okay, this one, there's 1 single peak. So this is a single peak. And then this one is also symmetric because you notice that both sides of the graph kind of look the same. It has this nice little curve. And then when you look at this one has a single peak, but this one is skewed and this is backwards. So your peak is on the right side. That means this is left skewed. So the data is getting pulled over to the left side. That's why they say that. And then if you wanted to have a different one, like if you're, let's see if I can draw in here. So let's say your graph did like the opposite. So your peak is on this side and then it skews over here. That would be considered skewed right. Okay, so over here on your left side, it's a skewed right. Okay, so then Okay, so this one was a skewed right, and it's also a single peak. Awesome. And then we have our box plots. Now our box plots are going to be a little bit different than our histogram. So our box plots, we only have to say if it's symmetric, skewed left, or skewed right. And it's all about the whisker. So notice that this whisker is a little bit longer on the left side. So this is a skewed left. This looks very symmetric because both of your whiskers look the same. And then this one, the whisker on the right side is longer. So this is a skewed right because your data is being pulled right. So that's how you guys describe the shape. You're gonna have to go back into your homework that you did last week and just describe the shapes of your histograms and box plots that you created. And then that's it. So you guys are gonna go back and finish that C11, C12 homework, doing the describing the data, and just make sure that you guys take a picture of all of your the entire worksheet and get that turned in. And as always, please feel free to just reach out to me if you have any questions. And I hope you guys are all doing okay and that you've gotten outside and enjoyed this beautiful weather this week. All right, bye guys.